And good morning, everyone. Thanks for coming. Today's guest speaker, I think, needs no introduction. Samczsun. I will just turn it over to you. By the way, we're going to keep this a bit informal. There are some things that Sam wants to go over, but please feel free to, I think, chime in with questions, and then we'll also do a bit of Q&A at the end. So have your questions ready for that as well. Sam?
Yeah, so I think informal is maybe a bit of an understatement. I have a blank Chrome window, and we're just going to start from there. So I think the premise was, to go over the transaction viewer tool that I released a couple weeks ago. And so one of the things we can do with it is maybe just sort of, for those who aren't familiar, sort of go over what it is. And then for those who are familiar, but maybe don't know all the various tricks I've thrown in there, because I completely refuse to release any documentation about the UI, maybe teach you a few cool new things. And then I think you might even get to see something as of yet unreleased. So let's hop in. And I'm going to pull up Brick because I don't know hacks off the top of my head. So if you're not familiar, basically, prior to releasing this, we had etx.info, which is sort of the go-to, oh God, I didn't realize they had that, which is sort of the go-to transaction viewer. And or I guess transaction trace viewer, we could call it. And the difference between etx and something like Etherscan, which obviously has some transaction viewing functionality built into it, is that etx will give you the trace. And so this is really useful, especially when you're trying to figure out how a contract got hacked, because this will tell you exactly what happened within the call, something that Etherscan won't tell you. At least it didn't at the time. As you can see, one downside is that etx is a bit slow at times. And there were also a few usability issues, like, if you wanted to copy this min return amount, you just can't. And so if you wanted to copy the signature or this data or whatever, you were just out of luck. And then, I guess various other things, like if you just had a really long thing, you're just like, okay, I guess I just won't know what the signature was. That's fine. But overall, it was really good. I think one of the most useful features is this account balance change, because it gives you at a very, very quickly, it tells you which accounts were impacted. If you were debugging a hack, you would be able to tell instantly, the sender gained a bunch of money. Okay, so which address lost a bunch of money? And then you would figure out who the victim was. Now, of course, since etx came out, Etherscan has launched their own decoder, which is also a little slow. I was really hoping it would load by the time I said that, but okay, there we go. But as you can see, it has one major benefit, which is if you click the function call, it takes you directly to the line of code where that function call is implemented. Of course, this is sort of offset by the fact that Etherscan's UI is just a giant pile of Ajax. And so, if you wanted to navigate to anything, you would actually navigate away from the page, and then, you can't do any like contextual browsing, right? Also, this, I guess it basically foreign code the data, but other than that, it's pretty good. It also lets you copy all the data. It also shows you the entire data. Although, again, you can see sometimes to the detriment of UI. There's also Falcon released by Blocksec team. Falcon is much faster. Oh, I swear this is not intentional. Uh, weird. I really wanted to like sing praises about Falcon, but then I think the way it works is that I think they actually run their own nodes that cache results as they execute blocks. And so if you try to view a transaction that's like too recent, it just doesn't have it, which is a downside, I suppose. So let's pick out something a little older. The Falcon's really fast. They also show you the balance change. They also show you this call tree. One benefit is you can actually go and edit the function selector map or the label map. And so, for example, if you wanted to, sort of redundantly label the sender as like sender, you could do so. And then now you can see the trace is slightly more readable, right? And then apart from that, I don't think there's much difference here. Oh, and then I think before we hop into this one, I should note that ETX also released their like new UI, which is equally slow, but is more useful. Maybe once it's loads, I'll be able to show you. Okay, so ETX in this new UI added a modal that pops up. And so now you can see that for these large calls, it's now more readable. And so this was sort of the state of the world when I started working on this. And this was sort of driven by my desire to have like a transaction tracer that was both fast, which, most of the others didn't have, but also had addressed all the quirks that I ran into while trying to debug hacks. And so for those who haven't seen it, this is what the UI currently looks like. Basically, as soon as you load a transaction, you get these 4 different sections of relevant data. You get the transaction info at the very top. You get the value change as well, but denominated in dollars at the time of the transaction. You get decoded actions, which admittedly is not feature complete. And then probably like the most important thing, which is the call trace itself. And so right off the bat, we have the same problem where you can see the data gets truncated if it's too long. And so to address that, one thing that you might not have known is that if you click the little prefix here, this is how you bring up the modal. And so you can see in the modal, you now get this much more detailed view of what's going on. So you get all the input data. If you want to format it in chunks of 32 bytes to do some hand analysis, you get this function signature here. So in the case that you don't actually know what the function is, you can sort of customize it here and try to figure out what it is. You get this tree view of the decoded parameters, and then some information about the logs that are returned. And then the second thing that I refuse to document is that if you shift click the arrows, you expand and collapse the entire subtree. And then I think the last thing here is if you click the little eyeball, you'll get, well, let's pick a good example. Maybe this one. Oh, uh-oh. Okay. Well, that's embarrassing. I guess that doesn't work there. Let's try, perhaps that should work. Yeah, okay. If you click the little eyeball, sometimes it will show you, well, it will always show you the storage changes, but sometimes it will actually be able to decode it for you. And so you can see here that in this call to wrap to transfer from, as we would expect, the balance of this address went down and the balance of this address went up. And so this is especially useful when you're debugging a hack against something like, well, maybe we can pull up an example here. I don't know what it's, does anyone remember what it's named under? Was it like Rory colon hack. Okay. Ruri hack. Surely CoinDesk would like, oh. Hellborn should like it, right? Okay. Rory Fuse hack. Oh, we can actually use this. This is courtesy of Falcon. But you can sort of see the point I'm trying to make with this is that if you can do storage changes or even the storage values as the call is happening, one of the most annoying things about debugging this hack was just trying to figure out why the interest rates were what they were. And hopefully this works. But yeah, here we go. So we can actually see exactly what the borrow index was at the time of execution, what it changed to, how the fees changed. This was so annoying. Trying to figure out at the time, it's checking what the rates were, etc. And so to be able to see the changes as they happen through the transaction, hopefully will help people in the future as well. And maybe this will even show us the other, yeah, here we go, okay. And then the last feature here is most of the time when we don't actually know what the signature is, to save you time from having to guess what the layout is, because given some time, you can figure this out, right? Like you're like, this looks like an address, this looks like an address, this looks like some number, this could be like an offset, right? And then a length of 1. But instead of making you do this, we can actually just guess what it is most of the time. And so we can see this function most likely is address, 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 and address array. Whereas we can actually decode that for you and show you the name of it as well. And so for this, at least, if you're ever like reverse engineering an MBV bot that doesn't use their own encoding, this one does. Oh, I know 857 definitely doesn't. Oh, they're just right, never mind. They just use the DS proxy pattern. Okay, this is a complaint I have about Etherscan too, is just, it's so annoying to search for stuff. Come on, give me something with like more data. Sure. Yeah, so you can see here, we were able to guess that this parameter is a tuple, so probably a struct of some kind. And these look like, some commands encoded in the most significant bits, and then some data in the least. And so that's sort of a rundown of the transaction viewer, I guess. Oh, perfect. Yeah. So I guess if people have questions or comments about this right now, we can go over that. But if not, I actually want to take some time to introduce you to something new I've been working on. Oh, Tenderly, yes. Sorry, I honest to God did not mean to forget Tenderly. I was going to intro them after Etherscan and then just, oh, not that one. Tenderly.dev. Did they change? Oh, it's .co now.
Good.
Yeah, so Tenderly has an Explorer as well, which is honestly like really feature complete. It's really good. You can see they actually show you which chain the transaction might be on. And so in this case, this is on mainnet Ethereum. And they also let you view the code of the call as it happens. And then of course they also let you view the state changes. I think the main difference is one tenderly doesn't fully support some of the stranger, like the weirder storage layouts. I think one that I stumbled on a lot while building that was DYDX. And so this is obviously a bit cherry picked, but just to give you an example. So if we pull this up, you can see that it does, the storage does get quite complicated, and we can actually see how this slot gets derived. So you can see it's this slot with this key, with this key, with this key, and it takes you to this struct right here. If you put the same in tenderly, unless they fixed it recently, I think you'll just get the hash, the storage slot itself. Solo margin. Weird. Oh, it actually, oh, I guess maybe no other changes occurred, so it just doesn't show you anything at all. Let's try the balancer vault then. Maybe we can see if it works here. Yeah, so even for balancer, you can see that this slot, which is again fairly complex, on tenderly, it wasn't actually able to resolve that. And so that's just one minor difference. And then I think the other one, this is a very personal opinion, so disclaimer, but when I'm viewing a hack, at least, this is just way too much. And it's also like it's like a very modern UI. And I just want like a very dense, very like one page, just like gives me all the information. But I think that's definitely a very very like personal taste sort of thing. So this is also why I much prefer like a dense UI like this. Like ETHDX again was great. If it wasn't also so slow to load big hacks. But I think that's sort of stuff that people might have already known and might have already saw. I did actually want to introduce you all to the latest one I'm working on, and also sort of make available to you yet. If you'd be interested in sort of beta testing it with me over the next couple of days or weeks, however long it takes. And so the new tool is located here. You'll need the credentials, which is I'll send that in chat. But basically, it's a VS Code for web interface with one custom extension. And the extension, unfortunately, relies on VS Code proposed features, which means that they won't actually let you publish the extension in their store. And so even if I wanted to publish it for desktop, at the moment I can't, which is very annoying. But yeah, so those are the credentials. And so I think there's a future where currently when you want to view an address, it takes you to Etherscan. But I have a lot of gripes about this experience right here and this experience right here, or rather, I guess, let's talk about the main thing. Sort of this back and forth right here. And so I wanted to walk you through how this tool works, and then maybe right off the bat, if anyone has sort of ideas or thoughts about how they might want to use something like this that is implemented, would love to sort of open up for discussion there. But so let's sort of hop in. Let's say you're investigating, or not even investigating. Let's say you're just exploring, right? Well, say you're checking out the compound ether contract. And so we'll just go ahead and pop that open. And so right off the bat, you're placed in this VS Code editor. And so already you have a much nicer viewing experience. If you want to, search with regex, for example, you can do that. If you want to use the file search, find all fail calls, you can do that. Unfortunately, there is no jump to yet, and that's just the limitation of the fact that this is running in browser, and so there's no language server. But hopefully, I have a solution to that in the future. I think one of the main differentiating factors is, or one of the main benefits here is that you get this notebook, which sometimes breaks. So if this breaks, yeah, okay. So just pop up in DevTools. I'm not sure why VS Code does this, but it does that sometimes. So, fuck. I should have noticed, yeah. Again, this part is a little buggy. It tries to generate an interface file that conforms to the layout of the contracts themselves. And so again, I mainly tested with dydx, but this is a good example for showing you why it's necessary. If you try to use dydx and you try to use like the API to generate an interface, you sort of lose the struct names, right? And so Etherscan actually, is very bad at this. It just says tuple. If you use something like api.ninja, it does a little better at this because I think it shows you, maybe? I guess not. Which one was it? Was it like vscan? One of these I think shows you the components inside the tuple. Okay. I guess not. But in any case, so one of the main frustrations is basically, given just the API itself, you don't know what the tuple type is called. And so that's why you have to generate the interface following the same layout as the contracts themselves. That way you can maintain like the fact that types.assetAmount is the struct. And then once you do that, inside your little notebook, you can do something like .get account balances, account.info. We'll just use dydx again, and number 1. Oh, except also it doesn't work. This is a really bad example. Let's struct that real quick. The demo is not working. Oh, I tried a semicolon. And probably some other things. This is sad. Okay, well, at some point this function will work better. But for now, you can sort of imagine how this is supposed to work. And then you also get a JavaScript cell, which lets you use stuff like ethers. And I showed you this in Twitter, but the idea is at some point you'll be able to transfer variables between the two. And so you could probably do something like, like you would generate a list of addresses to check here in JavaScript, and then you could do a bunch of stuff with it in Solidity or, mix and match, whatever you like. And then the final thing to sort of like make sure you can do everything you want in this one UI is to actually read the contract itself. And so if we pop that down here, you see this will automatically read you anything that doesn't require a parameter. But then if you do need parameters, again, you can just sort of pop in your query. And this isn't pretty formatted yet, but once it is, you can imagine we can get all the variable names and sort of show you the result exactly. One nice thing about this is that for the contracts that for some reason place, sender restrictions on view functions, or, if you want to call, if they don't mark a function as view, but it really is, you can change the sender, or you can also simulate, basically just do an if call on a function that isn't marked as view just to see what it does. And so hopefully that really gives you like maximum flexibility in interacting with the contract. And just to make it, even better, you can actually use units in these. And actually, you can also do math. So like, if for some reason you wanted to do like 40 GUI gas price in your simulation, but you didn't want to use 40, you could do like 15 minus 10 GUI, and it'll still work. You can also use ENS. So you could do like metallic.eth, and it should work. It didn't error, so, JK, I guess. Really just demoing all the things that don't work. Let me try. That's weird. I feel like, okay, well, that's unfortunate, but again, in theory, this should also work with ENS. And what was the last? Oh, right. And the last thing is, if you're interacting with something that takes in a bytes value, like a bytes 32, but it's actually a string, you can just like pass in the string and it'll auto encode it. And so that's sort of like this new tool. And so the idea is like, you can really just pop open this one workspace and just like, check whatever you want. I guess if you were a big BSC maxi, you can hop over to Binance and be like Pancake, Swap, I don't know, check the Pancake Swap token. And you get all your contracts on the side here. You can really play around with it as you like. So yeah, that's sort of this new tool I'm working on. I don't know. I've sort of run out of stuff to show in a very broken and hacky manner. So if anyone has thoughts or questions, not necessarily about the tooling, could just ask me whatever. I'm here for another 30 minutes. Like I said, informal is probably an understatement.
Sam, this has been amazing. You talked earlier about possibly us helping you test this. Do you want to kind of go through that? And maybe, it was great to see all these examples, but maybe you could just give a couple of, solid, I don't know, test cases or past that would be, an example of how we could help you out.
Yeah. So with regards to trying it out, again, the URL is here and the credentials are, I'll just repost it again. That's the username and password. And so you'll be able to, hop in and do as you like. If you haven't used vscode before, the shortcut to open the command palette is Control-Shift-P on Windows and Command-Shift-P on Mac, or F1 if you're using Firefox, because on Firefox, Control-Shift-P is bound to opening a new incognito window. And so once you open the command palette, you can use any of these functions. Most likely, you'll start with like either using the search or opening an address directly. And then, you're sort of free to explore with it as you like. And I guess just my goal is to make this, the way that into something that I would, prefer to use over Etherscan. One of my biggest gripes is that, you constantly, if you're trying to debug, like, okay, let's do a more concrete example. Let's say, because I did this a couple months ago now, I think. If I wanted to find try to find a bug in Arbitrum, right? I don't actually know which one is like the main. Oh, here. Let's try L1 ERC20 gateway, right? So if I was on Etherscan, I'd be like, okay, I guess I gotta pop open Redis proxy, but I gotta make sure I keep this tab open because I can't, interact with the contract on this tab. It has to be this tab, right? So this always has to stay open. And then now I'm looking through the code and I'm like, if I want to find something across all the contracts, I have this one box that, it just like jumps me through the thing. Like if I want to search function, I have no control over what it's doing. It just like jumps me through all these files. And I'm like, okay, I wonder where I'm going next. I don't know. Sometimes it doesn't sort the file on the top. And so I have to be like, okay, where even is like the main file I'm looking for? And then once I finally get there, now I'm like, all right, so this is an ERC20 gateway. It's got a bunch of functions that just call into the parent. And so now I got to find where the extended gateway is. Fortunately, it's right here. But the extended gateway extends the not extended gateway, and that is not right below it, right? So now I'm like, okay, I got to find, oh, my control F got captured by this box. So I got to search it again. And so now, if I'm trying to troubleshoot or just, review those two files, I just have to like scroll back and forth, right? I'm like, okay, this is doing something special and transfer and call, and like go back here, and right? So that's just like a giant pain. And then on top of all of that, this isn't a good example, but if you're doing like some troubleshooting on like synthetics, for example, if you're not familiar, synthetics has like an address resolver system, right? You give it a name, it gives you the address. You don't get to save your results, right? And so you're like, if you do one read, I mean, even here, I guess. I don't know what the parameters are, but like if you do like, one read here and you get some results and you want to find the next external call, you lose your first one, right? And so you either have to like copy it out somewhere. And so now you have like 3 windows here scrolling through, or you just memorize it, or you open it in a new tab. It just gets very ugly, right? And like on a system as large as Arbitrum, let's say I was doing this review and then I'm like, okay, I want to check out the inbox. So I open the inbox, but the inbox is also a proxy because everything in Arbitrum is a proxy, which, isn't their fault, but this tab is just, again, is useless, right? I just need it for this. And now I open the inbox and again, I have the same problem where I'm like, what is delegate call where? Time to try to find that file. Go back. There's like this allow list. There's, okay, so deliver message. Where is it? Here it is. It calls deliver to bridge. Okay, so now I want to know where the bridge is. And so I go back to bridge, open a new tab, hop over here. Redis proxy. I've got like 6 tabs open now, right? Because one for each, two for each contract proxy implementation. Head back over here. Oh, maybe I want to see like, can I get like a list of allowed outboxes? Oh, here we go. So if I want just to view all the allowed outboxes, I'm like, okay, 0, open a new tab. 1, oh, I put a space there, so it doesn't work anymore. Open a new tab. 2, open a new tab, right? So you can see how this sort of like just completely explodes in terms of complexity. You could maybe view their GitHub repo for this, but then you still have to find all the addresses, right, to like actually read the contracts. This is the problem I'm trying to solve here. So let me go ahead and just reset user data so we have a fresh workspace. And hopefully, I've never actually tried this. So this is a good test to see if my tool actually does what I want it to do. But let's go ahead and open contract on Ethereum. Okay, so we're gonna wait for it to load the implementation. Here it is. We want extended gateway. There it is. We want Arbitrum gateway. There it is. We want what Arbitrum messenger, like token gateway. There it is. Okay, so we got like all our tabs open. We don't need that anymore. We're looking through this. You know, we go, oh, but like, what's the bridge? Okay, proxy support is not great, but I do have to hop back here. I can do like a, oh, actually, this won't work at all, I think. Uh-oh. Yeah, because this is going to give me, okay, this is not good. Immediately foiled, but by my own laziness to like not implement proxy support. Yeah, so if you try to read this, you're going to get, oh, at least I can show you this maybe. So, for some reason, you know, OpenZeppelin won't let you call these functions if you're not an admin. And so let me, you know, shortcut open Explorer. Is there any way to find? Oh, I see if you use admin slot. Okay. So, you know, you might pop over to ethers. This should be injected in for you. I just haven't done that yet. I think this is the one. How you do it? Oh, JavaScript. JSON, no basic provider, get storage. Oh, get storage at. I think you have to wait too, right? Okay, so you get the address. This is a very, very not useful example, but yeah, okay. So now you can see that's actually the call kind of went through. I guess actually not good because I can't simulate. Oh, yeah, okay, so the call went through. But yeah, I guess foiled already because I can't read the thing, so I can't actually do what I did here. But again, if I just, where's the one I did the inbox stuff at? This one. I pop open this contract. We'll see if this works too. Okay.
What did you do just now? Like it was saying that the sender didn't have enough ETH, and then you did something really quick, and then it worked.
Yeah, so I had to change and this should again be the default, but I had to change the gas price from 50 to 0. I don't remember why I set it at 50. I thought I got another error where it was like the gas price was not kind of, but I guess maybe it's like if you try to use if you try to use non-zero, then it complains about base speed. But if you use 0, I guess it just bypasses that.
And obviously these simulations don't persist, right? It's not like you could like adjust the sender's ETH balance and then come back and run this, right?
Yeah, so this is so if you want to do that, I think ideally you'd be doing it in the notebook where this does persist. And so like,
really? Oh, nice.
Or the JavaScript one does persist. The Solidity one, this implementation is so hacky. It's just like a pile of AST rewriting. And so at some point I want to make it so the variables do persist. Right now it doesn't, and that's just awful. But yeah,
You're saying in the JavaScript window there, the second window, that if we were to do some writes, that it would persist from one to the next. Is that what you're saying?
Sorry, I meant the JavaScript variables themselves should persist. But the state. So if you want to get like actual state persistence, I think you would have to either like use tenderly probably.
Right.
Yeah, like a tenderly like one of the tenderly fork URLs, unfortunately. I'm not sure if there's anything I can do about that. Maybe like load a wasm built Foundry Anvil instance. Yeah, I'll have to think about that. okay, let's see if this works. So again, same example. I just want all the allowed outboxes, right? Because you know, when you're trying to find bugs, maybe one of the implementations is broken. If I was doing this on Etherscan, you know, I'm basically just like sort of doomed to do this until I hit some error that's like, oh, you're out of bounds, right? How do I do this here? Oh, actually, I'm not sure if I can do this here at all because the interface won't load, maybe? Let's try it. I don't think I can use the shortcut though. So I have to do like interface inbox load. Oh, and I want to be able to read. Um, oh, did it overwrite that? Interesting. Okay, so clearly some bugs to be worked out, but that's sort of what I'm hoping that both me trying this out over time and if anyone else is interested in figuring this out with me, let's see. Actually, is it possible to read the length of an array from a public, like from externally? I think you can only call its function, right? Oh. Uh, Snore? Uh, not like this. I'm not sure what I'm doing wrong. This might just be more jank.
What was the result at the end with no semicolon? Could that be doing anything?
No, so this is supposed to be, this is how you get it to print the result. I It's so jank, man. The Solidity compiler doesn't give. Oh, it's probably complaining because it doesn't. Oh yeah. So yeah, I can't even get the compiler error out because you know you could be doing something like this where the interface definition is like at the same scope as the code, and so I have to like parse it 50 like 4 times for each possible. It's really bad. Anyways, I think in this case the reason is because I have to define like this, or one of the reasons. I assume there's multiple reasons why this is not working. Yeah, like, oh, it's so bad. I could probably also do this with ethers, but trying to do that on the spot when I don't know how to use ethers is also a recipe for a disaster. So we can just sort of imagine that this works, but I don't know. Maybe the point has not been fully communicated because this is not complete yet. But yeah, theoretically, that's how you would use it, at least. I don't know.
I'll jump in with a quick question here. This is Engineer. I thought, did you just have some ethers or JavaScript earlier and now it's Solidity? So you've got potential for both unit tests and Solidity code?
Yeah, so that is the Solidity stuff will let you interact with the contract directly if you're more comfortable writing in Solidity. But acknowledging the fact, okay, one of the use cases here is basically like let's load something easier. Surely it will work with graph ether. Does the tag have any wrap either? Or is this not gonna work? Oh, he does. Perfect. Okay. So one of the things that I would usually do if I read this value on etherscan is I would like pop open the JavaScript console and be like, divide by 118. Like, he gets 0.05. But hopefully I will get in the habit of just like creating a new notebook and then switching over to JavaScript. And I can do that here instead. And then also, because I'm doing it in the notebook, it actually saves it. And so like I can, I can be like, like balance italic. And then one day maybe like be able to share this file with someone else. And so like you can sort of like follow along what I was doing as I was doing it. But yeah, the idea is you have the JavaScript cells for doing anything you can't do in Solidity, like floating point division or reading storage slots of contracts that don't expose them. Like, again, maybe you're like debugging some contract and you're like, there's a very bad example. Yeah, I mean, I guess we already did this, right? We pulled out the admin, but like normally if you were trying to find the admin for this transparent upgradable proxy on etherscan, you're sort of out of luck. You'd have to either find a transaction that, I guess any transaction, right? Because it's going to read the admin slot and you can maybe pop it in here. Or you can find the slot, which is going to be hard-coded here. And then you could pop over to like a terminal and do task storage or, whatever tool you want. But in this ideal world where you already have the proxy open and it doesn't clobber the other proxy that you had open, you'd be able to find it right here. And then you could, just pop open your notebook and just like provider get storage at. And then like your contract address, right? And so the JavaScript is here just for you to be able to do stuff that you can't do in Solidity. That's about it. I really need an easier way to copy this address. Like maybe add a copy address button here.
This is so cool, Sam. Thank you for sharing that with us. We got about 10 minutes left. Do you want to open it up for questions now?
Yeah, for sure. Happy to talk about whatever. Doesn't have to be about this again. Whatever's on people's minds.
Absolutely. Yeah. So anyone has a question, please feel free to speak up or drop in the chat. One thing I was thinking, Sam, as you were kind of going through this, like if we were to someday look at this kind of notebook as your, primary source of information, I mean, I know you could put a terminal window anywhere, but it might be nice to have a little terminal window here. You could fire off some cast commands or something like that.
Yeah. So the one problem is like, this is all running in your browser, and your browser obviously doesn't have Linux runtime in it.
Yeah.
So maybe you could do like a remote session, but vscode is like they're protective of things that are not their core editor, and remote editing is one of them, I think. So it might be tricky. Once the features I'm using get promoted to stable, then I can release this extension for the desktop one as well. And so that'll be even more flexibility on how, and then maybe you can use like the language server as well. And so definitely like, again, I think what I want this to be is basically like the ideal experience for browsing to be clear, for a power user who's trying to like make sense of some system of contracts on the chain, because I think this is like very mediocre, and I hate, like when I was, as another example, like when I was debugging the Binance hack, right? I had like 20, 30 tabs open of like all the different systems and all the different contracts. And obviously that use case doesn't fully apply here because I also had transactions and EOAs and whatever, but at least for the times when I was debugging the contracts themselves, like it would have been really nice to have them all in a tree here and to be able to run queries here and just like read stuff very simply here, etc. Yeah, so this already is a vscode extension. It just doesn't work on, specifically, it doesn't work on non-insiders builds of vscode. But presumably everyone's running a non-insider build, because why would you not? And so for all practical purposes, it doesn't work on anywhere outside of like this hosted environment, which is explicitly configured to be insider. On the last CTF, yeah, I was really surprised that the doc solved all the challenges. Also, like a bit sad, but it always, it's like good for the community, for the ecosystem, and then really bad for my ego because I was like, yeah, these challenges are going to be so tough, and then they like blew through all of it with hours to spare. But again, saltiness aside, it's like a really good sign that things that I thought was challenging is now being cleared by at least some members of the community in record time. And then yeah, trapdoor got solved with like a bunch of unintentionals. So that's my first like actual unintentional challenge. Yeah. Other than that though, I think it was really interesting just seeing people work through it. Really looking forward to not procrastinating the challenges for next year and getting that out on time. I actually don't know much about the context beyond that one screenshot going around and an email in my inbox that I didn't bother to read. But I thought Dan Finlay responded like they were gonna stop doing it or something. It sounded like it being generous, giving them like a generous interpretation, it sounded like it was just the lawyers did a thing, and then people realized that it sounded sort of like when people found out that in every social media's terms of service, it's like we have the right to republish your content in perpetuity, royalty free. And people were like, oh my God, this means that Twitter is going to take my content and steal it. And it's like, but in reality, it's just the lawyers want to make sure that they don't get sued. But it sounds like Infura's taking that out or doing something to it. So like hopefully it clears up. Yeah, I mean, when I did audits, like the 2 audits I did, that was obviously like a much more thorough approach. It's honestly like a bit mind-numbing, because I really don't want to focus on all the minor details. Like, yeah, but I think the audit process is basically, I mean, it still starts with the same process as like doing bug bounties because you want to get all the crits on your audit report. But after that, it's sort of just like very painful sweep through all the files. Just like making a very conscious effort that every time I look at a new function or at a function, so to be clear, like, we can't look at the same one twice, but like, making a very conscious effort to discard what I think I knew about it, in order to start fresh. And so maybe this is a very small contract. So, oh yeah, we have a gateway here. No. Yeah, so like, the bug bounty approach is scrolling past all this and being like, ooh, here's some like juicy stuff, and this might be cool because like if I'm the router, then I can control from, and then I might just like hop straight here. And oh, sorry, not there. Hop straight here and realize that, oh, I can't do that. The audit approach is like having to pay attention to everything else and being like, okay, so I see this line, pretty sure I know what its contract does, but like, let's just make sure that this is the implementation I was thinking of. In this case, it is checking the Xcode size. And it's like, okay, let's make sure that we keep in mind that this could be a constructor because that's a thing. And let's look at this function. Make sure I find the right one. And we're like, okay, get salt. Is this to do bad? Like, okay, we're doing code and address, it's fine. Hashing it, encoding with something, hashing it again. Let's check how this works. It's just being very thorough, right? It's very painstaking work, very mind-numbing, but I think probably the best way to make sure that you don't miss anything. I think maybe a good example, the pseudo swap. Oh, why am I? Yeah, old habits die hard. I could be doing this here. And then I could be opening all of these at the same time. Except I don't have an Etherscan API token, so I guess something failed. Yeah, like I said. Oh, fun. So I guess I need to trim the dots from the file name. Okay, guess we're sticking with this. One thing really interesting about the way pseudoswap architected their contracts is the way that the pseudoswap pairs check for authentication. So let's take a look at, can I find it in the next few minutes? System VM pair is routed. Okay, maybe not. Maybe it happens in here. Or, where is it? Oh, here it is. Okay, so the pair takes a Boolean that just says is router, and then it calls on a factory and check if it's the router or not. And again, this is just, man, I hate this already. And look, now my scroll is gone, right? So I have to like scroll them back down. It's just stuff that like I'm used to now, but I can't wait to break these habits and just not do this anymore. Oh, wait. Where's the thing I'm thinking of? I really want to show you this before I leave because this is really cool. But I can't find, maybe I'll just find the file. Is it in here? Oh, here it is. Yeah, okay. So you can see that when it creates a pair, they have this function, right? It's called isEthPairClone. And you can see the way it works is it constructs the runtime bytecode that it expects, places the implementation and factory in it, and compares it with the Xcode copy of the address. And if the runtime bytecodes match, then it's an ETH pair, right? And the way this function is used is in this function called isPair, which is used during the Wait, where is it? Is it here? Yeah. Okay. So obviously the pairs are authorized, or sorry, the router is authorized by everyone to do everything, right? And so if you could somehow convince the router that you're a pair, then you could just steal everyone's NFTs, right? And so you want to bypass this pair, but you don't control like your message sender, right? And so you have to, if you want to pass this check, if you want to pass this check, you have to have your bytecode match this exactly. And it happens that if your bytecode is exactly this, then you will call into the implementation that they're looking for. And that implementation will make sure that you can't magically call this function. And so this is an example of just like 20 lines of code that I spent maybe an hour going back and forth between, really convincing myself it worked as it's intended. Because it really takes some time to, like, for me at least, to wrap my head around and make sure like this actually was airtight. You know, during like a very casual bug bounty session, I might just be like, okay, I think this works as intended, and I'm just gonna move on. During an audit, I have to like really think about what exactly this means. That's like the difference here. And the relationship here, basically 4-byte is really slow. The problem, the main reason I make all my tools is just like the thing that exists is really slow, right? Like 4-byte is slow, so I made the signature database. Searching on Uniscan is awful, right? If you want to search like Uniswap, me too, for like Quincy, well, sometimes it just doesn't work. But you get like this really bad like Ajax dropdown. I'm sure you already know. All these results are fake, but like there's no sign of that. And you can't even control click into things. And then when you go back, your context is gone. It's just really annoying. And so that's why I built like the tags thing. This is because ETX was slow. This is because Uniscan browsing is bad. It's just, and also slow to some extent. But yeah, 4-byte, I do scrape 4-byte to put into my database. I also scrape some other things that I can't disclose yet because the people I scrape would get really mad at me. But suffice to say, I think it should be like the most comprehensive database. What I don't scrape is GitHub because I don't want to compile arbitrary code. There are people out there that scrape GitHub, and I think that actually that inflates the numbers and makes it look like you have a lot of signatures, but it's like for the most part not super useful because like if you scrape GitHub, you run into something with like a library function or a function that takes a struct, you don't have the struct definition and you don't know if it's a library or not. So you import it as like a malformed signature, and then it's just wrong, right? Especially when you try to like search by name. If you're trying to search like, you know, like or whatever, you're gonna get a bunch of junk results, right? Instead of like actual signatures that people use. In the future, I want to update this so that it also tells you where this came from, or like have this. But that would mean parsing the other giant data set I have, and I haven't got around to it yet. But yeah, that's a really long-winded answer.
Awesome. That's cool. I didn't even know you could use regex in the search window there. And that sounds like a great idea to have the source be clickable. I could see that being really valuable. I'm going to stop the recording now.